what is the inverse function of f of x equals 4x minus 6? And this is more along the lines of Algebra 1, Algebra 2 type problem here, all right? But what is the inverse function? And notice what we have here. We already have a function. F of x equals 4x minus 6. And some people say, well, what does that mean, f times x? No, it just simply means if I put a value in for x, I will put it in over here. In other words, like f of 2 would be 4 times 2 minus 6. So it's just a notation, nice way of saying, how about it? Those of you like to see it. Y equals 4x minus 6. Okay, so that's what it bounced to. Just a nice fancy way, but it's a good way of saying, yes, this will be a function. And what we're going to try to do is find another function that will be the inverse. Now, if you remember back in your first year of doing inverse functions in 8th grade and 9th grade, you started hearing about those, and basically the idea was that you would get a set of points, x's and y's, and you would interchange them, and that would be the inverse function, all right? That was what was going on, or that would be an inverse relationship, all right? So what we're going to do, we're going to take this a little bit further, and we're going to interchange x and y in this, and we're going to solve for our new y. You say, whoa, what was that all about? Watch and see. It's not that bad. It's not that hard. But let's see. First of all, what we're going to do, we've got that y equals 4x minus 6. That's a good start. And remember what I said, x and y we interchange. That's the whole idea of an inverse set of relationship with points. We're going to do the same thing here. We're going to let it be x equals to 4y minus 6. So now what we do, once we do that, first thing we do, we do the interchange, all right? Now we want to get this new y, this y here that's next to 4 now, by itself, by its lonesome, all right? What's keeping it from being by itself? Well, there's a 6, a minus 6 actually here. We're going to add 6. And we got to take care of this 4 that's attached by multiplication. Let's do one thing at a time, all right? Slow it down just a tad here. Let's add 6 first to both sides, all right? And that means we're going to add 6 over here. And be careful, folks. We don't want to lose that. We don't want to lose this over here. It's x plus 6. It's tempting to write that as 7x, but that's a 6. That's an x. They are not like terms. Leave them alone. That is as good as you get on that. So we got 4y left here on the right. We are going to divide both sides by, 4. We're going to divide both by 4. We're going to undo that 4y. And we have an expression. We have a function. We have y equals, goodness, x plus 6 over 4, which remember we can simply say that would be f of x equals x plus 6 over 4. Now you say, Ernie, how do we know that's a good answer? There's a lot of ways we could do it. I'm going to use the graphing calculator to do it for us today, all right? One way you can do it is basically take that new function and replace x. It gets kind of complicated, but you should come out with x again, all right? That kind of thing. Or you could do the old function and replace the new. And it's kind of complicated there. I know some of you are saying, whoa, whoa, whoa. But let's do it graphically, all right? So let's go to the graphing calculator, and we've got our first function already in there waiting for us, because we know that was going to be our problem of the day today. And we've got this new y equals, so let's go to y equals here, and we're going to put our new function in here, and because it's x plus 6 in the numerator, I'm going to put parentheses around it just to make sure, So we're going to put x plus 6, close the parentheses. It's the beauty of a graphing calculator. You've got these parentheses, and we're going to divide it by 4. And you say, okay, let's see what happens. It should be a straight line. It will be a straight line. Let's see what it looks like. Graph. There it goes. You say, okay, Ernie, how do we check that? How do we know those are any inverse functions of each other? Remember what we said about that we can interchange x and y. So they're going to be mirror images on the x equals y or the y equals x line. So watch as I put in one more line in here. Here it goes. Let's go down here to the third one. And we're going to put just simply the y equals x. And what we want to do is see if that thing doesn't split this into like a mirror. It works like a mirror as it will go right through the problem. Let's see what happens. And there it goes, right through there, a nice mirror. And you know what even will look better if we do a zoom 5 on this? We'll square up the screen. And let's see what happens there. Wow, there goes 1, there goes 2. And here comes our final little right through the heart of it. Isn't that pretty? Isn't that pretty? And again, it acts like a mirror. So that's the way we know that we did have the functions in each other. Now, you can also inverse of each other. Also, once again, you can do algebraically. It takes a little bit more time, but that was a quick check using your graphing calculator. And again, the whole idea, by the way, you say, did those things cross at a certain point? 2 and 2. In other words, the x and the y become one and the same at the intersection for those two functions. That's really cool.
For more math help, visit TNLearn.org.